Welcome everybody to another video regarding process safety leadership with Safe Energy Ops. I'm Joel Aponte and I've got my co-founder here, Felipe Rendon. Hey Felipe, how are you doing today?
Good, Joel, good.
Awesome.
Thanks.
So we're going to be going through a new increase in penalty for lack of process safety management. As we try to advocate for process safety leadership is at the core and the foundation of improving the risk profile, decreasing the risk profile and improving our track record as operators, safety consultants, and, just being in a high risk environment with different substances and materials. So without further ado, let me go ahead and share my screen. And I wanted just to kind of glance over an article that came through. This was published by gtlawinfo.com. Shout out to the folks there at that law firm, where they put out a blog post as recent as January 2023. And I'll just kind of read through this real quick. It says, no longer a slap on the wrist. OSHA continues to raise its maximum penalty amounts. On January 12, 2023, the U.S. Occupational Safety and Health Administration announced another increase in the maximum civil monetary penalties for violations of federal occupational safety and health standards and regulations. The new monetary penalties will be nearly 10% higher than the current maximum penalty amounts. Effective January 17th, 2023, the maximum penalty for willful or repeated violations is $156,259, a more than $10,000 increase from the 2022 maximum for the same kinds of violations. The maximum penalty for failure to abate violations is $15,625 per day after the abatement date. Finally, the maximum penalty allowed for serious, other than serious, and posting requirements violations is also $15,625, an increase of more than $1,000 from the 2022 maximum amount. Importantly, states that operate their own OSHA plants are required to adopt maximum penalty levels at least as effective as federal OSHAs. Any thoughts around that, Felipe?
Well, I think in the past it might have been, game is probably not the right word for it, but if you incur violations that don't sting very much, for lack of a better word, you might be inclined to drag out your correction of them, your compliance. This, I think is OSHA taking a step in the direction of, hey, if you don't have your programs in place, not only are we going to fine you for not having what you need, but we're going to fine you until you get it right, making it all the more important for you to have your programs in place, but also have something in place that keeps them up to date, keeps them effective. What happens a lot of times is you might make a correction to satisfy the fine, but the very next annual inspection or the same things are found, right? So having the right program in place that is able to sustain itself, I think, is going to be key. And as they continue to increase the severity of these penalties, it's going to mean a lot more for companies to have the right programs in place to avoid these heavy fines.
Absolutely.
What do you think?
Yeah, there's no easy way to put it. We have to enforce what needs to be done in process safety. And so slap on the wrist won't do it. Then definitely increasing the penalties and getting the attention that process safety management, process safety leadership at that is something to not take lightly or turn a blind eye. Okay, so let's go ahead, Felipe, and jump into today's process safety event CSB video. This was an ignore warnings explosion in St. Louis. And let's kind of reflect upon maybe some key process safety leadership takeaways that perhaps our audience could take back to their site, hopefully share, and hopefully, have some lessons learned around it.
Sure.
April 3rd, 2017. The Loy-Lange Box Company of St. Louis, Missouri. One worker and 3 members of the public were fatally injured when a pressure vessel catastrophically failed, causing an explosion that launched the pressure vessel into a neighboring building. The Chemical Safety Board investigated and found that over the course of many years, an area of the failed pressure vessel had thinned due to a known corrosion mechanism that was poorly controlled at the facility. And the CSB found that Loy-Lange repeatedly ignored clear warnings that corrosion was causing major problems within its operations. In fact, prior to its failure, Loy-Lange ran the pressure vessel normally, despite knowing that it was leaking. It was a safety emergency that unfolded in plain sight.
The incident at Loy-Lange resulted from a tragic series of circumstances: ineffective corrosion management, inadequate pressure vessel repair, a lack of inspections, and the absence of sound safety management systems. The result of those factors was that a severely corroded pressure vessel, which presented a serious safety hazard, was allowed to operate until it ultimately failed, resulting in the death of 4 people.
Loy-Lange manufactured corrugated cardboard, which is used to make other products such as boxes and retail displays. Part of the process to make corrugated cardboard involved heating paper using a steam generation system. The steam generation system used municipal water. The water was fed into a vessel called the makeup tank. There, the water was treated with chemicals and heated to approximately 200 degrees Fahrenheit to remove dissolved gases, including oxygen. This was necessary because oxygenated water is corrosive to steel equipment. The water then flowed from the makeup tank into a larger pressure vessel called the semi-closed receiver, or SCR. The SCR was comprised of a cylindrical center and 2 end pieces called heads. All 3 sections of the SCR were made of steel and susceptible to oxygen corrosion. The SCR was kept under pressure so that the water inside would retain more heat than it could at atmospheric pressure. From the SCR, the water was pumped to a generator that converted it to steam, which was used to heat the paper. The steam then cooled, condensed back into water, and flowed again into the SCR. At the end of the workday, Loy-Lange operators shut down the steam generation system, leaving the SCR filled with warm water. At the beginning of the next workday, operators would restart the steam generation system. During the daily startup, operators would initially block the flow of water into the SCR from both the makeup tank and from the condensed steam returning from the corrugation process. At the same time, the water remaining in the SCR from the previous workday was pumped to the steam generator. As a result, the water level inside the SCR would drop from its normal height of about 14 feet to about 2 feet. When the SCR was nearly empty, operators would then allow water to flow into it from the makeup tank. Loy-Lange's steam system was used to heat the water in the makeup tank. But at this point in the startup process, the water in the makeup tank may not have been effectively heated to approximately 200 degrees, so not all of the dissolved oxygen in the water was removed. Therefore, during startup, oxygenated water entered the SCR instead of the heated oxygen-free water used during normal operation. This presented a serious corrosion hazard within the steel vessel. Eventually, hot condensed steam returning from the corrugation process was available, and operators opened a valve to allow it to flow into the SCR, reducing demand for water from the makeup tank. But due to the design of the SCR, water did not flow easily through the bottom head. Operators could achieve flow in the bottom head by opening a manual valve and allowing water to drain from the SCR, a procedure known as a blowdown. But between blowdowns, a small volume of oxygenated water would remain trapped in the bottom head, and over time, the oxygenated water corroded the steel. The potential for corrosion was a known problem. During its time operating the SCR, Loy-Lange experienced at least 3 leaks due to corrosion. In response to a 2012 leak, a repair company removed most of the bottom head. The company patched it with new steel, leaving the remainder of the bottom head in place. But the original steel of the bottom head that was left in place was also thinned from corrosion. And between 2012 and 2017, it continued to degrade and eventually started to leak. On Friday, March 31st, Loy-Lange operators noticed a leak that appeared to be coming from underneath the SCR. A local welding company was contacted to assess the SCR, but was not available until the following Monday, April 3rd. Loy-Lange continued operating the leaking pressure vessel throughout the remainder of the day on Friday and shut down the steam generation system as normal that evening. On Monday, a Loy-Lange operator began the regular startup process around 6 a.m. At approximately 7:20 a.m., the vessel catastrophically failed. When suddenly exposed to atmospheric pressure, the water in the vessel flashed into steam, greatly expanding in volume. The result was a boiling liquid expanding vapor explosion, or BLEVE. The explosion launched the SCR from the Loy-Lange building and into the air. It traveled 520 feet, crashing through the roof of a nearby business a block away. Other debris damaged a third building as well as a parked vehicle. One Loy-Lange operator and 3 employees of the nearby business were fatally injured. During its investigation, the CSB found 4 safety.
Wow. Wow. So,
Incredible.
this is a process, building cardboard, that I've never seen before. So, it's something that I've never experienced. And, maybe at a glance or at face value, you're thinking cardboard, how dangerous might that be?
Just hearing cardboard manufacturer doesn't right off the bat make you think high danger, high risk, but there you go.
So what are some of the mental notes that you have, Felipe, regarding kind of what we just saw here? And as an operations leader, what's going through your mind seeing the documentary here as to maybe some of the red flags as a process safety leader that can be discussed?
Well, the biggest red flag to me, factor staring you in the face, is failure to stop the job. So this pressure vessel was leaking. That is an obvious sign something is not going correct. They continue to operate the pressure vessel. So there was no stop. We have to stop operating this. We can't continue operation until this is fixed. Now, that process safety leadership really comes into play here, because process safety leadership determines, is there a culture that's fostering a stop the job? Is there a safety culture where people feel empowered to say, we can't operate this vessel until it's fixed, knowing the ramifications to our production or to our, in this case, manufacturing volume? Do we feel like we have the authority and empowered to do that? Also, are there systems in place in our process safety management program that have us looking at these things on a regular basis and managing these risks? So are we doing our walk downs? Are we doing our inspections? Are these being recorded? Do we have plans in place to manage these risks? Those are all part of the process safety management program, and leadership makes it happen, right? Leadership puts the programs in place and makes sure that they're being carried out. And so the biggest red flag for me, not stopping this when there was obvious signs that something wasn't going right. Now, I'll add to that complacency. Looking at something day over day normalizes it in your mind, right? Normalization of deviation. You and I are both familiar with this from our background in the offshore petroleum processing industry. And what happens when you see something day after day is you become almost numb to it, numb to seeing it, and it starts to become normal for you. And so, we don't know exactly the ins and outs of the work environment in this case, or what the plant employees discussed, or what exactly they thought of this, but I can make a guess that seeing an exchanger leaking and then continuing to operate it day after day more than likely had that normalization process going on. And so you get complacent to seeing rusted equipment continuing to be operated. You go to work one day, nothing happens. You go to work the next day, nothing happens. And so, human nature, we start to think, well, it can't really be that bad. I mean, it's been like this for how long now, right? Normalization of deviation. So this is a clear example of why we have to maintain a chronic sense of unease, why we have to understand, especially as process safety leaders, what can go wrong. What can go wrong? This pressure vessel looks unassuming. From the outside, we see that it's operating. It has a small leak at the bottom. It's been like that for a week, 2 weeks. Everything seems to be fine. What can happen is what did happen, unfortunately, in this case, a pretty sizable explosion, and unfortunately, the death of 4 people. So how do you make that jump from we have a small leak to 4 fatalities? That's the kind of knowledge that process safety leaders have to carry with them and have to funnel down into their workforce to keep that chronic sense of unease in their minds, and have that chronic sense of unease push them to make the decisions such as stopping the operation, making adjustments, even if they might hurt on the economic side. The tough part about making good process safety decisions sometimes is that you might make the right call, but it might be hard to know whether you did or not, because you make the right call, you prevent something like this, you won't exactly know that this could have happened because it didn't, right? But at the end of the day, hindsight is 20/20, of course, but I'm sure this cost the company a lot more than what it would have to stop the operation of that pressure vessel. Now that they have 4 fatalities on their hands, reputational damage, etc.
Yeah, or put them out of business. I mean, we don't really know. I hear everything that you're saying there, and in my mind, kind of the phrase "what we don't know can kill us," or "what we don't know can kill others," comes to mind. And it may sound, in different contexts, it may sound a little bit pessimistic, but in this case, this is a perfect example of what they didn't know that could escalate from a leak. Like you said, it literally blew up and killed people. And I don't know this type of operation, this specific type of sub industry, right? And how much in-depth risk assessment, understanding of their chemical processes that they have, and research that they do, and the consequence modeling, or the after effects. But as we always say, it comes back to process safety leadership, because in a culture where process safety leadership understands that what we don't know may kill us or kill somebody else, stopping the job and understanding that we don't know, we really don't know, and it's okay to not know, but go ahead and stop the operation instead of finding workarounds, is kind of the reflection here. Hindsight 20/20, a lot of times it's easier to say, right, versus when you're kind of living in it, like you said, on a day-to-day basis. But it's about understanding that what we don't know really can get us. Let's see more of this information, if that's okay with you, Felipe, unless there's anything else that you want to share from the video.
No, as you said, if you don't know, stop and risk assess, right? Risk assess and ask yourself, what can go wrong?
To the explosion at Loy-Lange. Uncontrolled pressure vessel corrosion. Ineffective pressure vessel repair. Gaps in pressure vessel inspection and regulation. And deficient process safety management systems. The first safety issue is pressure vessel corrosion. Oxygenated water and steam generation systems causes corrosion in steel and must be managed and controlled. But at Loy-Lange, there was a history of equipment failures caused by oxygen corrosion in the steam system, and 3 documented leaks in the SCR, including the 2012 leak that led to the repair of a portion of the bottom head, 5 documented corrosion failures in other areas of the system, and numerous undocumented leaks in the makeup tank, enough for the company to replace the carbon steel tank with one made from stainless steel to attempt to address the issues.
We found that all of the corrosion failures occurred in components of Loy-Lange's steam system that when operated under normal design conditions should have experienced minimal or no corrosion at all. This points to the fact that oxygen was not properly managed or controlled within the steam system.
For instance, the CSB found that Loy-Lange steam system water routinely lacked sufficient concentration of chemicals called oxygen scavengers that are used to remove oxygen from the water. And Loy-Lange startup practices likely introduced oxygenated water into the SCR daily. The result was that over time, uncontrolled oxygen caused corrosion that thinned portions of the bottom head of the SCR so much that the vessel catastrophically failed.
Loy-Lange needed to adequately remove oxygen from its steam system water to prevent corrosion. But despite evidence of the hazard at the facility, the company did not take effective action before it was too late.
The second safety issue found by the CSB is pressure vessel repair. In 2012, the repair made to the bottom head of the SCR left a corroded steel ring in the vessel. The ring continued to corrode for 5 years until it failed on the day of the incident. The CSB found that this repair did not comply with regulatory code. The regulatory body with authority at Loy-Lange is the City of St. Louis. The City of St. Louis Mechanical Code required repairs of pressure vessels to conform to code from the National Board of Boiler and Pressure Vessel Inspectors. The 2012 repair of the SCR was performed by a National Board R-Stamp holding company, which meant the company was authorized to perform repairs to pressure vessels in accordance with the National Board Inspection Code. But the CSB found that the repair did not adhere to that code, which generally requires that all defective material be removed. As a result, the 2012 SCR leak repair was ineffective, incomplete, and dangerous, and it was the unacceptably thin remaining material from that repair that failed, initiating the incident. At the time of the 2012 repair, National Board Code required the involvement of a repair inspector, but did not require specific inspection points during the repair process to provide quality assurance. Instead, the level of scrutiny applied to any repair was left to the individual inspector's discretion. In this case, the repair inspector approved the repair plan without first evaluating the SCR, and the inspector did not personally witness the inappropriate repair to the SCR bottom head. Had the repair inspector seen the repair in progress, the inspector might have detected and refused to accept the inappropriate repair, which could have prevented the incident. Since the 2012 repair, the National Board made significant changes to the code, requiring inspectors to designate inspection points throughout the repair process. But gaps still exist. For example, the code does not specify whether the repair inspector must make in-person contact or view the job prior to reviewing and accepting a repair plan.
Understanding the extent of damage to a vessel is a critical step for a repair inspector to make when determining whether a company's repair plan is acceptable. We believe that this step should be specified in the National Board Code.
As a result, the CSB made a recommendation to the National Board of Boiler and Pressure Vessel Inspectors to update their rules to include prescriptive elements in the inspection process that would prevent the acceptance of a non-conforming repair or alteration. A third safety issue found by the CSB is pressure vessel inspection and regulation. At the time of the incident, the St. Louis City Code required an annual inspection of boilers and pressure vessels by city inspectors. But during the lifespan of the SCR, Loy-Lange never applied for an installation or repair permit, or otherwise registered the vessel with the city. Therefore, the city had no knowledge of the SCR and no means of proactively initiating an inspection. The CSB found that despite the regulatory requirement that the SCR undergo annual inspections, there was no record of a city inspector ever having inspected the pressure vessel. Furthermore, the city had not inspected the Loy-Lange steam generators generally since 2010.
Unfortunately, the City of St. Louis missed opportunities to prevent this incident. Had the city performed more regular inspections of the Loy-Lange steam system, it could have identified the unregistered SCR, sealed it from operation, and ensured its inspection, potentially catching the corrosion hazard before the vessel failed.
At the time of the incident, despite requiring an annual inspection by city inspectors, the city code offered no specific guidance on inspection methods or tasks beyond the annual frequency. The inspections were specified to be as thorough as circumstances permit. The City of St. Louis has since changed its inspection requirements to require that boiler and pressure vessel inspections be performed by an approved third-party agency rather than city inspectors. However, the city still has not adopted any specific inspection methods or tasks beyond the annual frequency, and neither city inspectors nor third-party inspectors are explicitly required to hold any inspection certifications, except in the case of certain boilers. As a result, the CSB recommended that the City of St. Louis Board of Aldermen revise the City of St. Louis Mechanical Code to adopt a national consensus standard, such as National Board Inspection Code Part 2, to govern the requirements for in-service inspection of boilers and pressure vessels, and revise the city's mechanical code to require pressure vessel inspections to be performed by a National Board of Boiler and Pressure Vessel Inspectors in-service commissioned inspector. Finally, the fourth safety issue the CSB found at Loy-Lange was the lack of an effective safety management system.
To prevent this incident, Loy-Lange needed to understand the hazards of its operation, implement and maintain safeguards to prevent corrosion in its steam system, and monitor those safeguards to ensure their proper function.
The CSB found that Loy-Lange's management did not understand the hazards of its operation and did not see a leaking pressure vessel as a safety emergency. The company failed to prevent corrosion in the SCR, had no inspection program, never investigated or addressed the root cause of the corrosion in its steam system, and repeatedly operated the SCR while it was leaking, including on the morning of the explosion. Therefore, the CSB concluded that Loy-Lange did not employ sound safety management principles in addressing the risks associated with corrosion in its steam system.
Had Loy-Lange instituted elements of an effective safety management system, including mechanical integrity, incident investigation, and effective corrosion prevention programs, the hazard of corrosion could have been mitigated and this incident could have been prevented.
As a result, the CSB made a recommendation to the Loy-Lange Box Company to develop and implement a comprehensive safety management system that includes elements recommended in industry good practice guidance publications.
Leaking pressure vessels can be dangerous and should be thoroughly evaluated to ensure that they are fit to operate. But even before a pressure vessel is compromised, there are many ways for companies to ensure that damage mechanisms, including corrosion, are properly understood and controlled. Doing so can prevent catastrophic incidents before they ever happen. Thank you for watching this CSB safety video.
I think in conclusion, it does come back to the fact that they didn't know, or maybe they turned blinds. I don't know, because I didn't work there, but to good process safety management practice. I mean, they didn't have a process safety management program. And so some smaller operations may think, or they may see themselves as low risk, low hazard. Maybe I don't have to have a program as big as maybe some of these oil refineries or, platforms or Fortune 500 companies. But guess what? Maybe you're not a Fortune 500 company, but you have the hazards and the risks and the potential to harm people and environment just as much. And I think that's one of the biggest takeaways from this particular incident.
Yeah, you have to understand the hazards at your facility. The hazards have to be well communicated, well understood by everybody. Before you undertake an activity, it's important for you to stop and ask yourself, do I understand what could go wrong here? What are my hazards? What are my layers of protection? So what's protecting me from something bad happening in this operation? Are there any gaps? If there are, how am I going to fix them? Can I fix them to the point that'll allow me to continue to operate? If I can't, then I need to escalate, sound the alarm essentially. So those are steps in our safe pause program from our roadmap, which is an essential part of operating any sort of hazardous process like this one. You want to have the safe pause integrated into how you do work on a day-to-day basis. It might be cut and dry or clear that it needs to be done for activities that have a clear start and finish. For example, maintenance activities, you're going to perform a repair of a pump. Before you get started, perform your safe pause. Where it gets a little bit less sort of clear is these sort of operational tasks that deal with equipment that's operated continuously, such as this pressure vessel. But it's just as important for control room operators, for those that are manipulating the process, to stop and ask yourself these same questions. Perform your safe pause. Make sure you have your hazards in your mind and your layers of protection, and that you've assessed whether those layers are healthy. Just like the commentator said in the TSB video, it does not appear that the personnel working at this facility really understood what could go wrong with this pressure vessel, what mechanisms there were for consequences occurring, how bad the consequences could be, and what their layers of protection were. If they allowed oxygen ingress into the vessel on a frequent basis, then that tells me those layers of protection were not understood, weren't evaluated. And so, you can't exactly fix gaps that you don't know you have. Really clear example of why it's important to foster that sort of culture at a facility. We talk about our focus is leadership here, and making sure leadership is driving the right behaviors, is driving the right culture. But, that's not to say that you don't have to have structures in place. You do. You have to have structures in place on the engineering side to make sure your equipment is properly rated, to make sure that your inspection program is occurring, that you're complying with regulations. All of those are part of your process safety management program, essential parts. From the leadership side, you've got to be promoting that vigilance, that awareness of hazards, of layers of protection. Is everything in place before I start this activity? And if it's not, I need to escalate and we need to stop the job.
Absolutely. With that said, even if you do not have a full staff of engineers in your operation, even if you don't know what HAZOP or a good process safety management program is, you are still a leader. And as a leader, it's important to know when to reach out for help. And so with that said, us at Safe Energy Ops, we are on a mission to help operations managers, safety consultants, advisors increase their process safety leadership without policy overwhelm or site pushback. And we want to invite you to a 100% free challenge in which we help you come out with a clear idea and a clearer picture of where your process safety leadership is at. And it's called the Increase Your Process Safety Leadership Challenge. Let me show you where to go to real quick. So in the Process Safety Leadership Challenge, it's 100% free. It's a good networking opportunity where you can come in and come out with a crystal clear plan around the process safety leadership status of your facility and what to do with it. So feel free to go to safeenergyops.com. There should be a link there so you can join us, network, and perhaps maybe this is the first time you read or hear about a process safety management program, and this 100% free challenge is a good start so that you can get a crystal clear roadmap as to how to assess and improve the process safety leadership in your operation. So with that said, go to safeenergyops.com. Make sure that you sign up the Increased Process Safety Leadership Challenge. Any parting words for today's audience, Felipe?
As you said, Joel, in our free challenge, we're going to be going through our framework on improving process safety leadership at your site. We're going to be discussing a lot about how to get your leaders more engaged, more motivated, and understanding the importance of process safety leadership and incorporating the right behaviors and culture at your site on a day-to-day basis, and how to sustain that. So excited for you to join us for that challenge.
Absolutely. Well, until next time, everybody stay safe and make sure that keep an eye out on your pro safety leadership so that we can all come back together.